everyone. This video is on nuclear fission and nuclear fusion. So this is the last topic that we're going to cover in our nuclear chemistry section. Nuclear fission is the splitting apart of a nucleus. So think of fission as splitting. So those two terms go together. And it's when you split a heavier nucleus into a lighter nuclei and neutrons. And so here is an example. You definitely want to recognize this example for your, if you're in my class, for the exam. And this is a very useful example, and we'll talk about why here in a second. But uranium-235, this is the isotope of uranium, it can be bombarded with a neutron. Here's a neutron there. And when this happens, it splits into krypton and barium, and then also some 3 neutrons here. Okay, when this happens, a great deal of energy is released. Okay, and so this right here, same equation, okay, the released neutrons can then come back and bombard other uranium nuclei. So this creates a chain reaction. So it keeps going, occurring over and over and over again. And so the critical mass here is just the minimum amount of uranium-235 that you need to sustain this chain reaction. And this nuclear reaction is the driving force. It is what is happening in nuclear power plants. So they use a large amount of energy released in fission. Okay, and then so this energy released is used to heat water to steam, which then produces enough power so that it can go to a generator, which then generates electricity. So this energy is used to boil the water, like I just said, creates steam, which turns a turbine and then generates electricity. So this is the reaction behind your nuclear power. It's also a reaction similar to what's behind bombs as well. Okay, so it's that much energy that is being released. This can bring some dangers. Having a nuclear power plant, as a lot of you know, we've had ones locally here in North Alabama, and the dangers are that you generate nuclear power, so you have possibility of radiation leaks. And then this can, as we know from, there's been several disasters from this, like Chernobyl, Fukushima. So those were a little bit different than just a small leak, but also the disposal of nuclear waste. So in previous videos I've mentioned actually both of these, and so nuclear waste is a big problem because these radioactive isotopes have such long half-lives. And so to minimize this, we use containment facilities so that we can contain these leaks, and they try to obviously be as safe as possible so that if it did leak, it would stay within the power plant itself. Nuclear waste is currently buried, but it's unclear whether this is the best method. There's places out in the mountains, under mountains, that they're disposing of this nuclear waste. But once again, this is a huge problem because it's still radioactive for so long. Could be thousands of years before these isotopes decay and are potentially, not radioactive anymore. And so nuclear fission is a very useful process, but it also brings about those dangers also. Nuclear fusion is the opposite. So this is the joining of 2 light atoms to form a larger nucleus. So here's an example. If you take 2 isotopes of hydrogen, they can react and form helium. So they form this helium nucleus here. So you take 2 lighter atoms, 2 lighter isotopes, and form a larger nucleus. This generates a large amount of energy also. However, fusion is not currently usable, okay, because as an energy source, because it can only occur at extremely high temperatures and pressures, okay, but you do want to know the difference. So nuclear fission, that's the splitting apart of a large isotope, and this is what was very useful with our uranium-235, okay, and then for nuclear fusion, think of fusing two things together, right? So nuclear fusion, okay, this is currently not usable as an energy source, okay, but it can occur at high temperatures and pressure. So be sure you know the difference between nuclear fission and nuclear fusion. All right, thank you.